Remember that the angle curve is the counterpart of the demand curve when we replace the price of the good with the consumer's income. Now, elasticity of demand, the price elasticity of demand, tells us how the quantity demanded responds to changes in the price. Now, we could do the same thing and look at income elasticity. So how does demand respond to changes in income? This is going to be useful to understand the impact of things like income taxes. So just like price elasticity, the income elasticity is the percentage change in demand divided by the percentage change in income. So again, the percentage change in demand is going to be, that's the proportion change in demand, so times 100. That's the percentage change in demand. Percentage change in income is that. Of course, the hundreds just cancel out, so we've got this, which is exactly equal to delta Q over delta Y times Y over Q. Remember, delta is the change. Delta Q is a change in quantity. Delta Y is a change in income. Now, if delta becomes very small, if the changes are very, very small, then we've just got the derivative. So the derivative of quantity with respect to income times income divided by quantity. This looks very familiar. If you just replace the Y with a P, you've got the formula for price elasticity. Now, how do we interpret this thing? What does this mean? Well, let's suppose the income elasticity is 1. Well, this says that if you have a 1% increase to your income, then your quantity demanded is going to go up by 1%. Is it possible that you could have a negative income elasticity? Yes, it is possible. And a good for which we have negative income elasticity, we call such a good an inferior good. Why do we call it an inferior good? It's because as your income goes up, you actually consume less of this good. So what are examples of this? Well, think of things like fast food. If you have more income, you're going to eat at nicer restaurants, so you're going to eat less at fast food restaurants. Or take the example of pirated goods. If you have less income, you're going to consume pirated goods, but as your income goes up, you don't need to pirate anymore, so you can legitimately buy the goods. When the income elasticity is positive, we call these goods normal goods. And what if the income elasticity is greater than 1? So the percentage change in consumption, or the quantity demanded, it outpaces the percentage change in income. Well, these are called luxury goods, because your consumption of this good grows faster than your income. So anything that has an income elasticity between 0 and 1 is called a necessity. Now, the shape of the income consumption curve tells us whether a good is normal or inferior. So let's look at a few different possibilities. We have 2 different budget lines, one here and one here. Of course, this one is for a lower income than this one. So as the income increases, you go from the lower budget line to the higher budget line. And as you go from the lower budget line to the higher budget line, let's suppose your income consumption curve is this one. So you go from this bundle to B. Well, what does that tell us about the 2 goods? Well, it says that as your income went up, you consumed more of both of the goods. So both of these goods are normal goods for you. Well, what if instead of going from this point to B, you went from this point to A? So your income consumption curve followed this line. Well, it tells us that you consumed more of good 2, but you consumed less of good 1. So good 1 is an inferior good, but good 2 is a normal good. On the other hand, if you had gone to C, so you followed this income consumption curve, then you consumed more of good 1, less of good 2. So good 1 is a normal good and good 2 is an inferior good. One thing we see from this picture, though, is that at least one of the two goods has to be a normal good. The income consumption curve has to pass through either this area, or this area. But no matter where it goes, at least one of the two goods is going to be a normal good. If it goes here, good 2 will be normal. If it goes here, good 1 will be normal. And if it goes here, both goods are normal. But in either case, no matter which of the three regions it goes to, at least one of the two goods has to be normal. Now we can actually prove that mathematically, even if there are more than two goods. Right? With just two goods, we saw that with the picture, at least one of the two goods has to be normal. Now let's suppose there were n different goods. At least one of them has to be normal. Okay, the budget constraint, if you had n goods, is this. The price of good 1 times the quantity of good 1 that you consume, plus the price of good 2 times the quantity of good 2 that you consume. If you add that up, for every good, the price of the good times the quantity of the good that you consume, which is the total amount of money that you spend on that good. So you add that up over all the different goods, all the way from 1 to n, that has to equal your income. So you're spending your expenditure, which is on the left side, has to equal your income. That's your budget constraint. Now if we take the derivative of this with respect to y, well, the price is just a constant. So we get P1 times the derivative of Q1 with respect to y, because remember, the quantity demanded does depend on the income. Similarly, the price of good 2 times the derivative of good 2 with respect to income, and so forth, all the way through the price of good n times the derivative of the quantity demanded for good n with respect to income. The derivative of the right-hand side is just derivative of y with respect to y, which is 1. All right, now we're going to do a little bit of algebraic manipulation. And what are we going to do? We're going to divide and multiply each of these terms by the quantity times income. So let me actually go back to the previous, get rid of that for a second. So look at this thing right here. P1 dq1 divided by dy. We're going to divide and multiply this by q1y, q1y, right? Of course, this is just 1. So if we divide and multiply, then we haven't changed anything. So we can rearrange that as P1 dq1 dy times y over q1 times q1 over y. Look at this thing in the middle. That's our income elasticity for good 1. So that's just P1 q1 divided by y times the income elasticity for good 1. Now let's look at this part for a second. What is this? What is P1 times Q1? Well, that's the amount of money. P1 times Q1 is the amount of money that you've spent on good 1. The denominator is your income. But look at your budget constraint for a second. You're dividing your income, y, among the different goods. So this is the amount of money you spend on good 1, this is the amount of money you spend on good 2, this is the amount of money you spend on good 3. on good n. So what you can do is, let's use theta I to represent the proportion of your income that you're spending on good I. So good 1 would be, the proportion of your money you're spending on good I would be Pi Qi divided by Y. So for good 1, this would just be theta 1 times income elasticity of good 1. Now that's going to be true for each of these. So the left-hand side of this equation is theta 1 times income elasticity of good 1 plus theta 2 income elasticity of good 2 all the way through theta n income elasticity of good n. We add those all up and we've got 1. Okay, so that's what we're going to do now. So we've got here, I've just multiplied and divided by Q1 times Y1, Q1 times Y to get this expression. And I've substituted in this and this to get this expression here. One thing to note here, one important thing to note, this can never be a negative number. This is always a positive number. Income is always positive. Price is positive, quantity is positive, so this thing's positive. Therefore, theta I is positive. So we've got a positive number, all positive numbers. Theta 1, theta 2, all the way through theta n. And we're multiplying income elasticities by positive numbers and adding them together. Is it possible that these could all be negative? So let's suppose it were that these were all negative, then there's no way that they could sum to 1, which is a positive number. Which means that at least one of these has to be positive. Therefore, there's at least one good among the n goods. There could be many, they could be all of them, but at least one of them has to have a positive income elasticity. So that's a mathematical proof that no matter how many goods you have, at least one of them has to have positive income elasticity.